Nice to be here again, 5th year in a row. Hope you enjoy already the conference, and I hope you will enjoy this session. So I'm Toon, I'm from Belgium, and more specifically from the left side of the country, the west of Flanders. That's the region where people have to be subtitled on national television, otherwise they don't understand us. That's also the region where there are more tractors on the road than normal cars. Also the region where a simple farmer's son can take the yellow jersey in the Tour de France. But of course also the region with very nice cities like Bruges, and the region where we have small family enterprises that became big business and had a worldwide impact. And of course we have our regional products. And one of the regional products I'm very proud of is Noust. Noust is the company I'm running together with my partner in crime. And Noust is a local Microsoft community, and with that community we want to make your world smarter and more efficient, and we do that from within our local strength and try to make a global impact over there. And we make solutions, end-to-end solutions on the Microsoft stack across various domains, and of course integration is an important one of them. And what's now very important at Noust is that we dare to come out of the comfort zone. If you always stick to the comfort zone and the technology you're used to, you won't learn any new things. But of course, by doing that, you will also make mistakes. If you make a mistake, it's not bad, but first of all, take responsibility to set things right. And secondly, try to learn from it. And preferably, try to make sure that your colleagues and even the community are learning from it. And that's why I'm here with this session. I think it's already 3 years in a row that I do sessions all over the place, sharing mistakes, my mistakes, Belgian mistakes, and today we are here for the world's biggest Azure integration mistakes. So the concept is, I've contacted over more than 100 Azure integration professionals over WhatsApp, LinkedIn. I did also on LinkedIn some announcements to get some input. Of course, some people, they just ignored me. No hard feelings for that. Everybody has busy times, both professional and in private life, so no worries for that. Other people said, no, I did not make any mistake. At least that I can't remember. Others were mostly blaming somebody else. Yeah, I know a guy in the company or at the customer side. But I was most surprised by the people who said, yes, I did make mistakes. How many do you want? So, of course, it's easy to show off with other mistakes. So let me lead by example and try to explain my biggest mistake. It was difficult to choose because I had quite a lot of them. But this one is a nice one. It was a use case where documents had to be processed as soon as possible. And from the moment they got uploaded on the SaaS product, they had to be processed as soon as possible to have a good customer experience. So of course, you have the client and the server. So from the client side, we could start polling for new events. And if an event occurred, the next time we poll, we know that a document was uploaded. But of course, you see in red, a lot of resources get wasted. And in the end, depending on the polling interval, there's always a delay between the event that occurs server side and the moment that you are aware of it client side. So the better way, and actually in real life it's also like that, if you look at project managers, I don't like the polling project managers, I like the webhook project managers. They just say, hey Toon, if something goes wrong, let me know, call me on this number. And if then an event occurs server side, the server will send you a webhook, so an HTTP call, and you get notified. Less resources are spent, and of course, you get notified sooner. But implementing a webhook system is not simple, because you take a lot of responsibility, you need to have retries and these kind of things. So that's why Azure Event Grid comes into play. So this was actually my design. The documents got uploaded on blob storage. We have the Event Grid basic system events for blob storage where you can get notified through a webhook, and I had a serverless function running to process the document. Serverless because sometimes 100 documents could be uploaded in 1 minute. At night it was very quiet. But I'm coming from a BizTalk background and always think about reliability, and if things go wrong, let's put some messages aside so we can reprocess them again. So once it worked, I updated my Azure function and made sure that I archived the messages in a subfolder. So later on we know which messages were archived and we can reprocess them. Maybe you can already guess what happened. But I wrote an endless serverless loop. If you write an endless loop on your machine, that's simple. Your memory or CPU is going through the roof, and you immediately notice this. But this one I didn't notice, to be honest. So how could I solve it? It was just a simple filter on your event grid subscription to make sure that you exclude the archived messages through naming convention or through a specific folder. But in the meantime, a lot of money was wasted. And money wasted, cost management is a very important aspect throughout the sessions that I gave the last 3 years. I've seen a lot of similar situations that I also want to share with you. People who did debug logging in IoT workloads, for example, that could give you a quite high bill if you do that through application insights. Another one is Databricks. Databricks expensive clusters that you typically schedule every hour or every night. But if you do the scheduling inefficiently and your Databricks cluster is almost running continuously, it can become quite expensive. Another one is incorrect auto-scaling. You automatically scale out, but somehow due to the rules that you defined, you don't scale in, so you are running constantly with the maximum number of instances. The use of a wrong data store, mostly looking to Cosmos DB, that is used for the wrong scenario, so you have a lot of cross-partition queries who can be slow and expensive. And if you do performance testing on Friday evening and you forget to downscale, it can also become. There's also a lot of waste in development environments. So also there, I think there are probably more than 2 solutions, but at least 2 solutions that I learned. The first one is to create a logic app that scans the activity, let's say, in every resource group. And if a resource group has been active for 20 days, for example, you send out an email to the responsible, which is hopefully in a tag available. Hey, do you still need this resource group, yes or no? And if they click no, you delete it. But an even more effective solution is actually wiping away a whole development environment every weekend. Sorry, I was already with the solutions and not with the mistakes. So how can you avoid it? First of all, configure budget alerts. It's not a lot of work. You can do it both on resource group level and on subscription level. You can set your budget alert. You can get notified on the actual budget, but also on the forecasted budget. So that's quite nice. If you will write an endless loop, the forecast will, of course, go pretty high. Another one is, and I think Mike in his session yesterday said it also, schedule periodic cost review sessions. On a monthly basis is typically good. If you just have, of course, a simple SQL database and an app service without any scaling, I don't think this is needed. But if you are building distributed scalable applications like IoT applications, you can save a lot of money with that. Learn from Azure Advisor. There are some good tips and tricks over there. And consider reservations over time. And more services are supporting reservations. So if you commit on a 1 year or a 3 year consumption, you can actually get to 60% discount over there. There are also free Azure services. And the last 2 I said already, but also look at the development environment, the playground for the developers. Also try to save costs over there. That's a very important one. So, lesson learned for me the hard way, perform cost control in various ways and on regular time intervals. All right? So the next mistake is one from Rahul, and it started actually with a good practice, where the security officer said, okay, we need security, network security on every single component in our environment. So let's do a very small recap of the session of Matthias. If you have a logic app running typically in an app service plan, how do we need to do that? The first requirement is that you have, I only want services or resources from within my network to access my logic app. In order to achieve that, you need to do 2 things. First of all, disable public access on your logic app. Otherwise, it remains available on public internet, so you have possible vulnerability over there. Secondly, give your logic app a private endpoint, so it gets a private IP address within your network. And of course, configure DNS the right way, otherwise you will not end up in your logic app. So by doing that, the inbound side, the incoming side of your logic app, of your app service is already configured correctly. But you also want the outbound side to be configured. You want your logic app be able to connect to databases who are network protected, or even to connect to on-premises, because that's the promise, of course, of Logic App Standards, that you also can do that. In order to achieve that, you need to configure VNet integration, which makes sure that from an outbound perspective, you can connect into your virtual network. This has to be in a dedicated subnet, that VNet integration. Another alternative is using an app service environment, which I highly recommend if you have a lot of app services or a lot of Logic apps running within app service plans. So the problem was now, after they configured the scalability, it didn't work anymore like after they configured the networking, the scalability did not work anymore like before. So before we dive into details of the problem, let's see the different scaling mechanisms. You can do vertical scaling, make your machines or your instances bigger or smaller, more or less CPU, memory, and storage. Or you can do horizontal scaling, adding more instances or removing instances depending on what you want to do. So if you look at this example, Rahul took a subnet /28. That gives you 16 IP addresses, but the first one and the last one, you can never use it. And then you have three additional IP addresses that are reserved for Azure management to do, I think the management plane, DNS is also one of them, so you cannot use them. So in the end, you have 11 IP addresses left. So let's run our Logic app in a single instance. So we will take one of the IP addresses. We can start scaling out. Add more instance and more instance. So you see now we take already 3 IP addresses from the 11. Now we can do another type of scaling, and that's the scaling up. Let's make the instances bigger. But what the product team cannot do is they cannot modify an instance. They cannot cut something off. So no, what they need to do, you have 3 small instances. You want to scale up to bigger instances. What they do under the hood is they provision first 3 new bigger instances. Of course, they also need their IP address. Then they swap gradually from your smaller instances to your bigger instances. And then they remove the old ones, and over time, your IP addresses get released. But in the meantime, you see actually that during a scale-up, you need a double amount of IP addresses. So that was the problem at Rahul's side, that actually, if you want to do scale-up and scale down, you can actually use a maximum of 5 instances within a /28 VNet, subnet, apologies. So if you do networking in combination with scaling, size really matters. So think about it. When calculating your network sizes and subnets, really think about your scalability. It's not because you have a Logic app that you just need to take, I need 1 IP address for my Logic app. It could be a lot more if you want to scale out, but also scale up. Next one is from Ricardo. It's not really a mistake that he made, but I really want it in the session because I see it too often all over the place, so that's why I wanted to point this out. So the use case is quite simple. They decided to go for more low-code integration. Hey, let's democratize integration so everybody can be an integrator. So they've chosen for Logic apps. So Tom, fictitious person, fictitious developer. He started his journey in Logic apps, so he went to the Azure portal, created a new Logic app, connected to a few connectors, and made everything work. Tom was a good guy, a smart guy. He also configured notification if something goes wrong. We get notified and we can intervene. But the company was a victim of a hacking attempt. During that hacking attempt, Tom's account got compromised, and luckily it got locked out, which is a good measure, of course, if you see suspicious login. So his account got locked out. So far, so good. But then suddenly integration started failing. Failing because a lot of these integrations were running under the user account of Tom. He logged in various connectors that were using his personal credentials over there. Luckily, Tom had notifications to a Teams channel, but of course, these notifications were running under his account. So after his account got again reversed and it was active again, they had to re-authenticate manually all the service connections in order to make it work again. So what's the message here? Systems should not run under user accounts. I think it's a very simple one, but I see a lot of integrations that are still not following this logic. If you want to make sure that this doesn't happen in your environment, you can block certain connectors that allow this kind of login. On Microsoft Learn, you will find an easy way how you can do that with Azure Policy. So you can easily say, these 20 connectors, I don't want them to be used in my organization. Just write an Azure Policy and you can sleep on both ears because nobody will be able to create such connections. I think it's also good stating here Power Automate. Unfortunately, it's a very nice, good service, but for the right use case. I really believe that it's useful in personal productivity, where you want to maybe automate some emails, where you want to go to a SharePoint list, get some data from SAP. That's all good. It's also good if you create a Power App. You want some back-end connectivity from the Power App to maybe SAP, to Salesforce, whatever. And to do that back-end connectivity within the user context, because it's a user that is logged in. I think that's a good practice because then you are sure that the user only sees the data that he or she has access to. But please don't use it for enterprise integration. I've seen it already positioned as a replacement of BizTalk server. That's not the intention, of course. So there's a lot of similarity between Logic Apps consumption and Power Automate. They're also running the same engine. But in enterprise integration, you need a lot more than that, and that's why Logic Apps standard was, of course, introduced. So be aware of that. I think most of you know, but within many organizations, this rule is not followed. So the lesson learned here is, integrations, and actually most systems, they should run under a system account. Preferably use managed identity. If not possible, go for a service principal. Okay. Managed identity is a kind of a service principal, but with service principal I mean that you authenticate with client ID, client secret, or client certificate. And if that is not possible, you need to go maybe for just system credentials, connection strings, and these kinds of things, but always with the lowest access needed. The fourth mistake is one from Bill. And there the scenario was actually, again, a good practice. That they wanted to introduce queuing within the integration landscape, so they had complete decoupling. Bill, his Twitter handle is BizTalk Bill, so we are coming from the same background, from the BizTalk background. So if people have been around for BizTalk, they probably recognize this. The typical pub-sub pattern that you used to have in BizTalk. In BizTalk, you were forced to do that. I think in Logic Apps and Azure Function and whatever integration that you do, it's also good to follow similar patterns, to make sure that you have that decoupling and load leveling. So when there is a lot of messages coming in from system A, that's towards system B. You can stop the integrations for a while and process the messages at your own pace. So that's what they've done. And they used, of course, Azure Service Bus for that. So Azure Service Bus, very important. If you compare that with the message box that you used to have in BizTalk, the message box that was transactional, MSDTC made sure that everything was one transaction. In the cloud, with Service Bus, you need to deal with at least once reliability. So there's the peak log pattern that you should use. Don't use the receive and delete, because then you can lose messages. But you need to peak a message, and then that message becomes unavailable for others to read. And during the log duration, you can process the message, and then you can acknowledge it or reject it. If you reject it, it will be retried and so on. And eventually, if you cannot process it, it will end up in your dead letter queue. So that's at least once reliability. Semantics, if you use Service Bus, always use this one. What was now Bill's problem? First of all, the peak log pattern was not available in Logic App Standard, unfortunately. After a while, it became available, but only for stateful Logic Apps workflows. And then after another while, kind of a in-between solution was proposed that you had to enable VNet integration and so on to make it work. What's the main reason for that? It's Logic Apps and Service Bus, it's not the best marriage. because Logic App is a fantastic orchestrator, but it's an HTTP orchestrator. It connects systems to each other, but in the end, all those connectors that have been built, those are just HTTP calls. While Service Bus talks natively AMQP. And in AMQP protocol, if you want to acknowledge a message, it needs to come from the same connection that received the message, which requires some stateful component in the backend, and that's why that workaround was there. Good, the product team is working on that, they're on it. But what I want to make sure is, maybe you should consider Event Grid if you're working with Logic Apps. I didn't thought I would have ever said it, because I was not a big fan of Event Grid because it was the push-push model. But as you heard previously, you have now also the pool semantics available in Event Grid, which gives you actually the same reliability like you used to have with Service Bus. So you can do the peak log pattern. Okay, the naming of the pattern and the actions is different, but the concept is exactly the same. So you have also a reliable queuing system now with Event Grid. It's not a full-blown queuing, so you don't have the message deduplications, you don't have sessions to have your FIFO, but at least you have that at least once reliability. And it talks native HTTP. And Logic Apps also talks native HTTP, so that's maybe even a better marriage. And if you're not convinced yet, let's talk about network security. If you have a service bus and you need to enable network security on top of it, you need to go to Service Bus Premium. For Event Grids, it's much cheaper, so you can have the same reliability. You could have the HTTP protocol and cheaper networking. So I'm not sure, I don't say always use it, but at least consider it when you're focusing mainly on Logic Apps. Azure Functions, for example, that integrates fantastically with Azure Service Bus, but Event Grids is a good match with Logic Apps. So the lesson learned here from Bill, also the hard way, is always prototype your Logic Apps connector before architecting solutions with them. Because there are a huge amount of connectors, the quantity is high, the quality is not always on the high side. So before you rely on a connector, which is a fundamental part of your solution, I would say do a proof of concept, do a prototype with it before you really rely on it for all your architecture work. So thanks for sharing that one, Bill. The next integration mistake I want you to learn from is one from Mike. I'm not sure if it's really a mistake, because I think I would have done the same, but still a very important one I want you to share with you. So the use case there was, okay, in the organizations, they wanted to have an enterprise-grade integration platform. Back in the days, because this decision had to be taken in 2019, and at that time, you only had two options. You had the Logic Apps consumption, and you had the integration service environment. Integration service environment is not the same like the integration environment that you've seen yesterday with all the monitoring features. No, let's talk about it right now. So the integration service environment was a dedicated compute that you got, dedicated capacity, quite expensive, but at least you had your reserved capacity, and you could run as many workflows that you wanted, of course, within the physical capabilities of that capacity. The scaling, Logic Apps consumption, like you know, they scale automatically. Within your integration service environment, the scaling did also automatically, but if you want to scale your capacity, you need to define a rule for that to add an extra node or to remove it again. And then the value proposition of that integration service environment, it was mostly to have dedicated compute, premium performance, and network integration. Because back in the days, I think private endpoints, they did not exist yet. Service endpoints, they started maybe coming out over there. So what decision did Mike take? He took, of course, the integration service environment back in the days. What's now the problem? Unfortunately, services, they retire. So 2 years ago, there was an announcement that this summer, the integration service environment will be retired. And of course, that's not a nice message to hear, because this gives you quite some implementation costs. Okay, there was good guidance to migrate to Logic App standard, but in the end, it's a lot of testing, a lot of development, a lot of DevOps that needs to be done. And his customer had to pay twice for Azure because they were still running on the integration service environment with dedicated compute. Even though it was only running one service or one Logic App, they had to pay for that one, and they had to also already to pay for the new Logic App standards. So it's important if you make the choice to embark on a new Azure service, think about the life cycle. Typically, services they get in private preview, they go in public preview. Sometimes they remain in public preview and never go to GA. And sometimes they get deprecated. And I'm not only talking about services, but also specific features of specific services, they get deprecated. So if you want to be updated on these deprecations, and in the past it didn't used to be a problem, but nowadays I see more and more deprecations coming to us, so it's something we really have to deal with. So if you want to get updated, you can go to Azure Updates and get emails. There's also an Azure Deprecations board, community board, but the nicest one is, and I discovered that half a year ago, but this is a very nice workbook that you have within Azure Advisor that shows you all the Azure services in your environment that will become victim of deprecation. And they give you a link to the explanation and also a link to the documentation with the solution. So if you want to remember one thing of this session, it would be, if you go to the office on Monday or on Wednesday, whatever, check out this workbook because it will give you an overview of all the potential deprecations in your environments. So, lesson learned the hard way from Mike, always validate the life cycle when adopting a new Azure service. Then the last one for today, one from Matthias. And there the scenario was that they wanted to have real-time synchronization between one system and Dynamics 365. So Matthias, we know him, he tried to do best practices as much as possible, using Azure Functions and the pub/sub pattern with Azure Service Bus. Yeah, that was a good design. But still, on the first day, a lot of events had to be synchronized. A lot of data when they go live was synchronized. And actually, they overwhelmed Dynamics 365 with too many requests. So they were not able to deal with that. You could ask why, because we did load leveling. We put a queue in between to make sure if there are a lot of messages coming from the source system, that the destination will be protected. Well, yes and no, because your consumer on the right side, that's a scalable consumer. So by default, it will scale out to process the messages as soon as possible. But your integration platform, it can scale as much as you want. Of course, your destination needs to be able to follow. So if you want to limit the scalability within Azure Functions, there are a few settings that you can do. You cannot exactly control it 100%, but you can control the number of concurrent instances, and then also within an instance, you can also limit it over there. Also, when using Logic Apps, you have concurrency control, which is a fantastic feature. You have it both on your Logic App trigger, so you can say, this Logic App can run with a maximum of 20 invocations, for example. And you can have it in a for each loop, which is fantastic. You can loop over 1,000 items, but with a maximum of 10 at the same time. And that way, you have your scalability and your serverless capabilities, but you still limit it a little bit so your backend system does not get overwhelmed. So the lesson learned here, before I go to the next one, think about exponential backoff. Because if you constantly start retrying, the problems will only become bigger and bigger. So retry with an exponential backoff, and eventually maybe also implement circuit breakers, which just stop sending messages. If you only get exceptions back, just stop a little bit with processing and retry after a while. Otherwise, the problem becomes bigger and bigger. So a lesson learned here is, always test for scale. And in many scenarios, you need to limit your integrations to protect your backend systems. So as a conclusion for this session, first of all, and a lot of organizations that I see are still not doing this, but is invest in your Azure governance, in the foundations. And you start already building integrations, AI solutions, whatever, but you don't have your foundations right. Your foundations, it's about resource consistency, making sure that you have naming conventions and a good split of environments. It's about cost management, make sure that you have the responsibility within the organization, make sure that you have budget alerts and these kind of things. Security and identity. Identity, make sure it's protected, make sure you have MFA. But also network security is a very important one. Make sure that you have the landing concept, like Matthias explained, so you can easily create a new landing zone which is immediately secure by default. And make sure that nobody in your organization can create app services with a public endpoint. These things are very important. Release management, of course. We like to work read-only in production, so everything that happens in production should be going through your release pipelines. And last but not least, business continuity, disaster recovery. I don't say you always need it, but at least talk about it and make sure that the requirements are clear. When we do a project, we always talk about these things so we are on the same page. What's your RPO that you want to do? Do we test the failover, these kind of things? It all costs money, so it's just a matter of investments versus risk that you want to take. And then another thing, adapt to a distributed cloud. In the past, everything was running in your local network on the same server eventually, but in a distributed cloud, we are dealing with at least once reliability, with idempotence that you need to think about, so a lot of important things. Microsoft has good guidance on that. It's the well-architected framework. It's a lot of documentation, but if you're looking specifically for some guidance, it can really help you. So by that, I just want to say, somebody wanted to take a picture, otherwise. I just want to say, dare to jump, come out of your comfort zone. You will probably make mistakes, but everybody here in this room makes mistakes, so just take responsibility to set things right and make sure you and maybe your colleagues learn from it. So thanks a lot, enjoy the break, and enjoy the rest of the conference.